So welcome to room 48, the room with the AC conditioner, the air conditioner. Now, this experiment has to do with infrared radiation and how it behaves, or how different materials, if you like, interact with infrared radiation. Now, the equipment you're going to need for this experiment is 3 test tubes. One is absolutely clear, it's a normal test tube with nothing around it, and so this is our control. A control is when there's nothing added, nothing taken away, so that you know what would normally happen under normal circumstances. So this one is our control because it's absolutely normal. The second one is a boiling tube with aluminium foil wrapped around it, and the last one is a boiling tube with some black paper wrapped around it. You'll need a lamp, which you can see behind the test boiling tubes, a measuring cylinder, a stopwatch, and of course the 3 thermometers, which are currently placed in the boiling tube. So the procedure for this experiment is very, very simple. What you're going to do is you're going to take your measuring cylinder. This is a 50 ml measuring cylinder, and you're going to fill it using normal tap water to 25 milliliters. Now you need to be looking at this at eye level. That's to give you an accurate reading to get it to 25 milliliters. If you're not looking at it at eye level, you're not going to have the same amount of water in each boiling tube, and therefore your results are not comparable. So you take your 25 milliliters of water and you add it to your boiling tube. Right. You get some 25 milliliters more, you add it to this one, and 25 milliliters more and add it to that one. Then what you're going to do is you're going to place your thermometers into it. So you place your thermometers into it and let it rest for about a minute so that it equilibralizes. I can't say that word. So about a minute later, you want to check your reading and see what it's saying. So, and again guys, you have to look at it at eye level. So I'm looking at it at eye level, so I'm going down to it, and I'll show you I'll prove it to you on the camera that I've gone down. So I've gone down to eye level so that I can get the best, most accurate reading, because this is what it's all about, and see what it is. So at eye level, I'm going to give it a bit of a stir because I want to get the average temperature of the water. So whenever you're taking recording for this experiment, you want to stir the thermometer a little bit. It's 24 degrees Celsius, and you're going to do it for each one of those right at the beginning, okay? And that will be your starting temperature. So once you've got your starting temperature, you want to record it in the table. I'll show you what the table looks like. Okay, so your table would look something like this, where it's time in minutes, and you're going to have 1 to 15. I could only fit 1 to 9 on my whiteboard. However, you can fit 15 into your book. You'll have to turn your book sideways. If that needs to be the case, then so be it. So I've got my 3 types of boiling tubes, my control, one with the aluminium foil and the one with the black paper, and every single minute I'm going to record the temperature. Now what I've forgotten to do, however, and so I'm going to do it now, is there's going to be time 0. So this one here should not be time 1. It's 1 minute, it should be 0, and then this one should be 1, 2, 3, 4, etc, etc. Okay. So once you do that, you'll have your results. But the question is, how do you? So we've done time 0, but what's happening at time 1, 2, 3, 4, etc. What you're going to have here is you're going to have the lamp. You're going to switch the lamp on, and as soon as you switch the lamp on, you're going to start your stopwatch. So switch the lamp on, start your stopwatch, and then fill in this table as you go along. So what's the temperature at 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, etc. I just want to say the reason why I've got this at the back, so the lamp on the behind the boiling tubes and not in front of it, is because if you look here, the boiling tubes are more exposed at the back than they are at the front. So it makes sense to have them at the back. And the other thing you want to make sure is you want those to be as close to the lamp as possible, so they absorb the most heat as possible. And that's it really. And obviously you got to think about your control variables. So what are you keeping the same throughout the experiment? what's your independent variable, that's what are you changing, and obviously what's your dependent variable, what results are you collecting. So that's the first experiment. I'm going to go on to the second experiment to do with infrared radiation now. Now with this second experiment, what we're looking at is which one is the best emitter of infrared radiation. That is to say, which one will give off the most heat and cool down the quickest, and which one will cool down the least. So which one's a good emitter and which one's a poor emitter. So again, you're going to have your control test tube with nothing on it. You're going to have your silver aluminium foil, and you're going to have your black paper on it. Now the difference between this one is obviously we want the water to be hot to begin with. So we're going to boil the water using a kettle. Again, measure at 25 mils from the boiling kettle to the measuring cylinder. Now obviously safety hazard here, it's hot, be careful, okay? Then what you want to do is you want to reach it from the top, don't reach it at the bottom, don't try and pick it up from the bottom because that's where it's going to be hot. If it is safe to do so, if it's cool enough, take it from the top, pour it in, each one, so 1, 2, 3. So if you fill up 50 mils and you go 25, or you could have 3 measuring cylinders and fill up each one with 3. So fill up measuring cylinder 1 with 25, measuring cylinder 2 with 25, measuring cylinder 3. You could be working in a 3 and you can all pour in the water at the same time. Then what you're going to do is you're going to stir the thermometer for a little while, record your initial temperature, and then once you're happy with that, once you've got time 0, you start your stopwatch and you record the temperature every minute for 15 minutes. And you're going to be using exactly the same table, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 15. Now, next, what you can do with your results is you can make a graph, and the graph is going to be the temperature against the time. Now, obviously, your graph will need a title, you need your axis, never forget the units, and so I've got graph of water heating up. So this was the first experiment, and I've made up these points. So I've said it's all 3 started at 23, and then they increased in temperatures at different rates. So I've got my dots going up this way, my X is going that way, and my triangle's increasing the slowest. So I'll have a key, and I'll say what X is, what the X's are, what the dots are, and what the triangles are. Now, obviously I just made up these results, but you guys will use your actual results table to make this graph. So the graph again is temperature against time in minutes. And then you'll do exactly the same thing for the other graph, for the graph of the water cooling down. You'll have 3 different points, so you'll have 1 for black, 1 for aluminium, 1 for control, and see what happens. But obviously you're going to expect the graph to start from the top because it's going to be boiling water and cool down over a certain time period. So hope this makes sense, hope this will make it easier for you. Goodbye.